In today's video, we're going to be learning about alternative methods of extraction, life cycle assessments, and recycling. The Earth's resources for metal ores are limited. One of the metals we are worried about is copper, as its ores are becoming rarer and rarer to find. Luckily, new ways of extracting copper from low-grade ores have been developed. These include phytoextraction and bioleaching. These methods avoid a lot of energy costs compared to traditional mining methods of digging, moving, and disposing of large amounts of rock. Phytoextraction is where plants absorb mineral ions through their roots. The way this works is plants are grown on low-grade ore. These contain less metal than normal ores. Plants absorb the metal ions through their roots, and then the plants are harvested and burned. The ash left behind will contain a higher concentration of the metal than the original ore. The ash is then processed to obtain the metal. Phytoextraction is slow, but it has reduced the need to obtain ore through traditional mining and allows us to conserve the limited supplies of more valuable ores. Bioleaching is when bacteria break down low-grade ores to produce an acidic solution that we call a leachate. This contains metal ions. The metal compounds can then be processed to obtain the metal. For example, copper can be obtained from solutions of copper compounds by displacement using scrap iron or by using electrolysis. Bioleaching is generally used to extract copper. It doesn't need high temperatures, but it can produce toxic substances that may damage the environment. Life cycle assessments are carried out to assess the environmental impact of products at each stage of its life. This process is referred to as a cradle-to-grave analysis. The stages assessed include extracting and processing raw materials, manufacturing and packaging your product, use and operation of the product during its lifetime, and the disposal at the end of its useful life. We often need to take transport of the raw materials and the product into account, as these can be transported huge distances back and forth from country to country via ships or aeroplanes before they even end up at your home, school, or workplace. The use of water, resources, energy, and production of waste can be fairly easily quantified. However, allocating numerical values to pollutant effects is less straightforward and does require value judgments, so a life cycle assessment is not a purely objective process. Selective or abbreviated life cycle assessments can be devised to evaluate a product, but these can be misused to reach predetermined conclusions, for example in support of claims for advertising purposes. The reduction in use, reuse, and recycling of materials by end users reduces the use of limited resources, use of energy sources, reduces the waste and environmental impacts of a product. Metals, glass, building materials, clay ceramics, and most plastics are produced from limited raw materials. Much of the energy for the processes comes from limited resources as well. Obtaining raw materials from the earth by quarrying and mining also causes environmental impacts. Some products, such as glass bottles, can be reused. Glass bottles could also be crushed and melted to make different glass products. Metals can be recycled by melting and recasting or reforming into different products. The amount of separation required for recycling will depend on the material and the properties required of the final product. Recycled metals allow us to save on resources, but they do first require the metal to be collected. We then make new materials out of these recycled metals.